I hate reading from lists, and hopefully you've known that in the videos that I've done that, but I kind of actually have to do it on this one. So let me demonstrate each of the numbers here with the table that I have below. So first of all, data is going to be, or a table is going to be represented as a two-dimensional structure, okay? There's going to be our different attributes for this particular table, and then we're going to have each table row, which is a tuple or row, whatever you want to call it, represents a single entity occurring within that table. Okay? Each table column represents an attribute. I already did that one. That's kind of funny. For each intersection of row and column represents a single data value. So notice, by the way, now, this is a single data value. I know you're saying spaces in between, stuff like that. Yes, but that is the product description. Now, by the way, for those of us that are programmers, we need to think about the different data types that each of these columns would really hold. We also have to worry about that we validate it as well. So these are also topics that come up later on in this particular set. So if you're a programmer, you've got some experience in this, and you're really going to need to do this. By the way, and this is for future attractions, notice there's no spaces in here. Sorry, nulls, spaces. Whew, big difference. There's no null in here. There's no values that does not have, well, it's a blank, a null. These are all, we'll talk about that here in a little bit. Anyway, all right. Each column has a specific range of values. There's your validation I was just talking about. The order of the rows is immaterial to the database management system. Now, I'll be honest with you, I'm a little bit retentive when it comes to that. Notice there's nothing in here that's exactly set up. Let's see, vendor code, yes, that's all out of order. Product code, it doesn't look like there's a certain order that I like order myself. In your DBMS and your overall interface with it, you can easily set it to show from 1 to whatever, or alphabetically you can do that. You can do that in your Google Sheets or your Excel or whatever. You can have that same feature, and I like doing that myself, but it is immaterial. It really is. It will be in there, just the order that you have this in is not, it's immaterial. It's there, but the order's immaterial. Each table must have their own attribute or combination of attributes that make it unique and identifies each row. This is one way of knocking down any type of data redundancy, to be frank. Also notice again, in these educational examples, the tables are going to be rather small, not with the number of rows that we have, but the number of attributes that we have. And that's actually good practice, because in reality, you might have some things that need to be related so that you can fix things. And we'll talk about that here with the ER diagram. I'm getting ahead of myself. Notice I'm constantly thinking about design at the same time. And because of those of us that have done programming before, think of this as a big object, and here are the different data members that we're worrying about using getters and setters and all that stuff. This is a very similar idea. It's the same idea as what you had in programming using objects. This happens to be just one object called product. So again, by nature, as a programmer, I'm already designing in my head to make sure I take care of all the characteristics of a relational table. Here's your exercise number 1. You're going to see this come up a few times, so just heads up. Matter of fact, you're going to see another exercise right after this, different table. But anyway, what information does this table give? Don't just look at the table headers or their attributes, but also the data itself. I want you to list as many informational items as possible. I'm not trying to get, you know what? I'm going to take that back. I want you to get detailed on this. I want you to think of that, especially for those of you that are programmers, are the data types, the ranges. Notice again, why do I have a blank here? Why do I have a null here? Think about all the different things. Notice how we have date of birth, the different types of. This actually gives out a lot of information. So I want you to think about this as if you were starting this table off from scratch. Let's pretend you didn't know how this was set up. How would you create this from scratch? That's what I want. So the more information that you give me, I know you might skirt on a few things here, but honestly, the more information that you give me here is only going to help you in the long run when you have to create it on your own anyway. So use that time. Shouldn't take you more than a few minutes, but think about it with all the details that you need for this particular exercise. Please. So now I'm worried about tables themselves. So using the database, this is a database this time because you have many tables that are inside it. That's why the terminology changes here. And from previous chapters that we've already covered, which haven't been too many, so you kind of know where to go, I want you to create an ER diagram for the database or a relational diagram. And then I want you to create an entity relational diagram, an ERD, for this database. I would suggest finding a simple tool to draw the relationships out. Draw.io might be one. Can't remember one that I found out. But I want you to dig the web a little bit. And I want you to actually tell me what you found for this. We might use it in class if it's really nice and easy. I can't remember the one I had. DIA. That's it. It's DIA. I think it's .org. That's another one that actually might be a good one too. That one's really easy to use. I use it all the time. But anyway, can't believe I remember it. Anyway, sorry. That's what I want for this particular set. So start with that. Keep it simple, especially this one. This is really doing previous chapter stuff.